So now we will continue the same theorem, part number 2. It's continued, it has not been finished. The outer measure has the property of countably countably subadditive, right? So proof we have done so far that AN, the collection AN is contained in union of, I, INI. This AN is covered by this collection. It implies union of AN is covered by union, double union, IN, comma, I, by this collection. Now, since the collection INI, इसमें दोनों की ही वेरिएशन है, N and I, is countable. क्यों? Being the union of countable number of, countable number of countable collection एंड किसको कवर कर रही है ये कलेक्शन? ये यूनियन ऑफ एन को कवर कर रही है, ठीक है जी. इट इम्प्लाइज द प्रॉपर्टी ऑफ आउटर मेजर, इट इम्प्लाइज एम स्टार यूनियन ऑफ एन, राइट? दिस इज लेस देन और इक्वल टू समेशन. अब दो है, दो यूनियन है, इट मींस दो समेशन आएंगे, वन इज एंड अदर इज. So here you will have length of n, comma I. Otherwise जब आप लिखते थे ना A is contained in union of IN, तो आप लिखते थे m star A is less than or equal to summation of length of IN, right? तो यहाँ पे हम इस तरह से express करेंगे. So we have already written that the summation of length of IN, this is less than or equal to. So I will put the value number 1 as summation of length of INI, IN, comma I. This is less than or equal to. This is less than only one, not this one. Summation of length of INI with respect to I. This is less than or equal to m star AN plus epsilon by 2 raised to power n. ठीक है जी. So it implies, ये हम ऊपर substitute कर देंगे, it implies m star union an. This is less than or equal to. एक summation बाहर आ जाएगा, एक summation की पूरी value अंदर put हो जाएगी. Summation an plus epsilon by 2 raised to power n, right? So अब summation हम अंदर ले जाएंगे. This is summation n, m star an plus epsilon is independent of n. So here we have the infinite GP, and the formula for infinite GP is E upon 1 minus R. So this is summation m star an plus epsilon. First term is 1 by 2, combination is 1 by 2. So that comes out to be as summation m star an plus epsilon. Right? So ultimately what you have got, so this is equal to summation n m star an plus epsilon. That is हम कहाँ पहुंचे थे? m star union of an, right? This is less than or equal to summation of m star an plus epsilon. So this result holds for every positive real number because epsilon is a arbitrary positive real number. So letting लिखते हैं हमेशा, letting epsilon tending to 0, we get m star union of an is less than or equal to summation of m star an. This we want to prove. It implies m star is countably subadditive. Is countably subadditive, right? So now we have a corollary. ये इनफाइनाइट काउंटेबली हमेशा मोस्ट प्रोबेबली हम इनफाइनाइट कलेक्शन के लिए, फाइनाइट काउंटेबल में दो होते हैं, फाइनाइट एंड काउंटेबली इनफाइनाइट, ठीक है जी, इनफाइनाइट कलेक्शन के लिए मोस्ट प्रोबेबली इसको यूज करते हैं. सो नाउ वी विल हैव remark या corollary. We can write it as corollary 1. M star is finitely subadditive. M star is finitely subadditive. So what does it means? अब हमने काउंटेबल कलेक्शन मींस इनफाइनाइट वैल्यूज थी हमारे पास, अब हमने फाइनाइट के लिए प्रॉपर्टी होल्ड करनी है. सिंस बाय द प्रीवियस थ्योरम as m star is countable subadditive, therefore m star union k running from 1 to infinity ak, particularly यहाँ पे define कर देंगे, is less than or equal to summation k running from 1 to infinity m star ak. ठीक है जी. Now taking ak is equal to 5 for all k greater than n, जो भी n से बड़े हैं उन सब के लिए ak की जो वैल्यू है वो 5 हो गई. ठीक है. इट इम्प्लाइज m स्टार यूनियन k रनिंग फ्रॉम, अब जो k n से बड़े हैं यानी सिर्फ बचे k रनिंग फ्रॉम 1 to n, उसके बाद सारी वैल्यूज क्या है 5 है. ठीक है. ये देखो ये बन गया आपके पास ak, ये मैंने n वैल्यूज ले ली, उसके बाद जितनी वैल्यूज है यानी an plus 1 यूनियन an plus 2 so on up to, ये सारी की सारी वैल्यूज जो है ये 5 है. सो दिस इज, और यहाँ भी हम सेम लिखेंगे, दिस इज लेस देन और इक्वल टू समेशन k रनिंग फ्रॉम 1 to infinity, यहाँ आएगा 1 to n m स्टार, और यहाँ पे हम लगाएंगे, कहाँ तक लगाई हमने k की वेरिएशन तक. इसका मतलब जो आगे है m स्टार ak प्लस 1, ठीक है जी, प्लस m स्टार ak प्लस 2, ये चलता जाएगा सोना तो. ठीक है. और यहाँ से आपके पास आ जाएगा, इट इम्प्लाइज ये बन जाएगा m स्टार, ये सारे बेटे 5 हैं, ये ऑल आर 5. सो इट इम्प्लाइज यूनियन ऑफ किसी भी पूरे एक आपके पास सेट है उसमें 5 यूनियन करोगे द सेट इटसेल्फ, सो यू आर ओनली लेफ्ट विद यूनियन k रनिंग फ्रॉम 1 to n ak, क्योंकि ये सारे सेट्स ही क्या हैं, ये सारे सेट्स 5 हैं. और इधर उन सेट्स का क्या है मेजर, और 5 सेट का मेजर m star 5 is always equal to 0. So you are only left with summation k running from 1 to n m star ak, और बाकी सारे क्या हो जाएंगे 0 plus 0 plus 0. So it implies what we have proved. It implies what we have proved, m star union k, m star union k running from 1 to n ak. This is less than or equal to summation k running from 1 to n m star ak. It implies m star is finitely subadditive. So this is the corollary. It means when this question will be asked, you have to prove the previous theorem. For countably infinitely prove karke, then you will prove for the finitely, right? Now next theorem is Next theorem. If A is a countable, isko corollary, this is actually corollary number 2. If A is a countable set, then M star A is equal to C. कोई भी set countable हो, there is no need to find the measure. We will directly say that the measure of that set is equal to 0. So let's come to its proof. हाँ जी, since A is countable, since A is a countable set, and we know that every countable set is represented in the form of a sequence with distinct elements. It implies A can be expressed in the form of an infinite sequence with distinct elements. Distinct elements. It implies A can be expressed as, so A is equal to A1, A2, A3, and the general element is AN, this one, right? इस सेट का मेजर निकालना है, इसका मतलब इस सेट को पहले एक कलेक्शन के अंदर बंद करना पड़ेगा, ठीक है जी। एनक्लोज करेंगे हम, एक ओपन इंटरवल की कलेक्शन में इसको एनक्लोज करेंगे। लेट एप्सिलॉन ग्रेटर देन 0 बी गिवन, then enclosing each an, then enclosing each an in an open interval. end point नहीं है, infinitely many points है, ठीक है जी। हर एक पॉइंट को इंटरवल के अंदर बंद करना है। कौन सा इंटरवल लिया? IN. So AN minus epsilon upon 2n plus 1 and AN plus epsilon upon 2n plus 1. So this collection we have taken to enclose all the points of the set A for all n belongs to n, so that अब an है, an से एक छोटा ले लिया, एक an से बड़ा ले लिया, इसका मतलब an इसके अंदर आ गया, so that an is contained in IN for all n belongs to n. It implies the union n running from 1 to infinity an is contained in union n running from 1 to infinity IN. So हर set A का member union of IN के अंदर आना चाहिए. So that is सारे set A में एक A elements में कौन पड़े हैं? A1, A2, so on up to this. ये सारे elements हैं. तो ये सारे elements की जो union है वो पूरी की पूरी इस open interval की collection के अंदर आनी चाहिए. So we will open all these sets, singleton sets. It implies A1 union A2 union A3 union dash dash is contained in union and running from 1 to infinity IN, right? So हम इसको फिर एक सेट अब हम इसको इस तरह से लिख देंगे. So now to this is contained in union and running from 1 to infinity IN. Very simple. And it is A is contained in, इसका नाम ही क्या था? A. Union I running from 1 to infinity IN. And we know that by the property of iteromere, this is less than or equal to n running from 1 to infinity summation of length of IN. So now I will substitute the value of IN here. Summation n running from 1 to infinity length of IN. IN means AN minus epsilon upon 2n plus 1 and an plus epsilon upon 2n plus 1. ठीक है जी, इसकी length निकालेंगे, length of this set. Then we will take the summation. So what is the length? So length is b minus a. It comes out to be b. An, you are left with epsilon upon 2n. You are left with epsilon upon 2n. Epsilon is independent of n. So we are left with the GP series, and after solving the GP series, what you will get, A upon 1 minus R, you will get epsilon. So it implies M star is less than or equal to epsilon, letting epsilon tending to 0 positive. So what you will have, M star A is less than or equal to 0. But the first property of outer measure says M star is always greater than 0. But M star A is always greater than 0. On combining this, it implies M star A is equal to 0. So what does it mean? It means every countable set has the measure 0. Every countable set has a measure 0. Next, now we will do the corollary number 3. The set, prove that the set this is uncountable. Now, using the properties of outer measure, we will prove that this set is uncountable. Otherwise, we have another formula to prove that it is uncountable. Right? Let, if possible, so the corollary was the set 0 to 1 is uncountable. We will use the concept of measure theory. Let, if, yeah, any interval or another statement क्या है? Any interval of positive length is uncountable. Right? So, coming to its proof. So, मान लिया, let if possible. Let if possible. Let if possible, the set 0 to 1 is countable. We will do it by method of contradiction. Is countable. Right? So, अगर ये countable है, तो अभी हमने corollary number 2 की, then the measure of this set is 0. And we know that the outer measure of an interval is its length. This is equal to 0. What is the length? Length is 1 minus 0. It implies 1 is equal to 0. How can we say that 1 is equal to 0? Which is absurd. ये absurd क्यों आया? क्योंकि हमने assume क्या किया था? Interval 0 to 1 क्या है? Countable है. Hence our supposition is wrong. The interval 0 to 1 is uncountable. Right? Next corollary. Corollary number 4. Any set with the outer measure 0, outer measure different from 0 is uncountable. कोई भी सेट जिसका आउटर मेजर जो है, कोई भी सेट जिसका आउटर मेजर 0 से डिफरेंट है, 0 नहीं आ रहा, वो सेट क्या है? अनकाउंटेबल. लेट A be a set such that उस सेट का मेजर 0 नहीं है, such that M star A is not equal to 0. प्रूव क्या करना है? वो सेट अनकाउंटेबल है. टू प्रूव A is uncountable, मान क्या लिया? लेट A be countable. और अगर A काउंटेबल हो तो इसका मतलब हमने अभी प्रीवियस corollary में किया, then M star A is equal to 0. This is, लेकिन M star A क्या है? Given क्या है? Not equal to 0, which contradicts to the given hypothesis. Which contradicts to the given hypothesis. Hence our supposition is wrong. A must be uncountable. Right? Now, we will do some examples of, examples of sets with examples of countable sets. Examples of countable sets with outer measure 0, right? Set of natural numbers. N. It implies m star n is equal to 0. ठीक है जी? Next, set of integers. Z. It implies m star z is equal to 0. ठीक है? Next is set of rational numbers. All are countable. Q implies m star q is equal to 0. Set of all algebraic numbers. Countable hai. This is countable. The name is A. It implies m star A is equal to 0. So these are the examples of countable sets whose measure is equal to 0. If a set is countable, then its measure is 0. But if the measure is 0, it doesn't mean the set is countable. Right? So we will do the example tomorrow. Now I'm coming to some of the very simple example. So we have done all the corollaries related to subadditivity. So now example number 1. If m star A is equal to 0, then prove that m star A union B is equal to m star B. Since proof, I'm starting the proof. Since m star is finitely subadditive. अभी आपने फर्स्ट क्रॉलरी की थी. इट इम्प्लाइज, इसका मतलब क्या था कि अगर दो सेट्स पड़े हुए हैं, उनकी जो यूनियन है, दिस इज लेस देन और इक्वल टू आउटर मेजर ऑफ फर्स्ट एंड प्लस आउटर मेजर ऑफ सेकंड. नाउ वी हैव गिवन दैट दिस इज इक्वल टू 0, सो दिस इज m star b. It implies m star a union b is less than or equal to m star b. First is done. Less than is done. Now we will prove that it is greater than. As B is contained in A union B. It implies M star B is less than or equal to M star A union B. देखिए. So on combining 1 and 2, it implies M star A union B is equal to M star B. Very simple. So this is all about today's lectures. I hope the point is clear to all of you.